I'm Pete Soderling. I'm the founder of Data Council and Data Community Fund. And thank you for joining us this summer in our new series. We've been shooting for new episodes every other Thursday, and just as a way to keep engaged with the community and to bring them content and thoughts from top folks behind open source data projects. So today, I'm really excited to have Drew Banin here, who's both a co-founder and the chief product officer of Fishtown Analytics. Drew, I have my DBT shirt on. So for those who don't know, Fishtown is the main company behind the development of DBT, the data build tool. And so Drew's here, and just to introduce Drew has a background in computer science. He's worked at a variety of startups over the years in data engineering, data analytics type capacities. And so Drew, we're super excited to have you. Thanks for jumping on with us.
Yeah, thanks for having me on, Pete. I'm a long-time listener, first-time caller. Been attending Data Council events for the lifetime of Fishtown Analytics. So happy to be here. Thanks for having me.
Awesome. Well, yeah, thank you. So Drew, something interesting I discovered on the Fishtown website. I just wanted to start with this. This is a quote: "Analytics engineering is the data transformation work that happens between loading data into your warehouse and analyzing it. DBT allows anyone comfortable with SQL to own that workflow." So talk to me about what is DBT. How do you, you can unpack that statement however you'd like. There's a lot going on there, but let's start with what is DBT.
Sure. So DBT is, we've got a punchy tagline for it. It's all about doing the data modeling work that happens between sort of like ingesting data into a data warehouse and then eventually at the other end reporting on it. And one of the big changes we've seen take place in the analytics ecosystem over the past, say 5 or so years, is that there's a shift from sort of all-in-one BI tools that will ingest data, transform it and report on it, to sort of like a, maybe we'll say an unbundling of these tools. And you get sort of dedicated data loading tools, you get data transformation tools, which is kind of where DBT lives, and also reporting tools like, say, Looker, Mode Analytics, Tableau, et cetera. And so what we kind of identified, say 4+ years ago, was that these data warehouses are really powerful, and they're actually a great way to do all the sort of like encoding of business logic that is required to do any sort of real analytics. And you can do all that work in SQL. It's super accessible to anyone with a SQL background or sort of knowledge of how to write SQL. So DBT is at its core Apache 2 licensed open source software where you can define what we call data models in SQL files that specify some transformation. And then DBT itself is able to manage the dependencies between these SQL files and sort of help you build relations in a database in dependency order. So you might have events that roll up to page views, that roll up to sessions. DBT will order those, parallelize things if necessary, and take your SQL select statements, persist in the database as tables or views at a high level.
And would you say that the rise of DBT has been sort of in parallel of this transformation from ETL to ELT? This is a sort of something that's being commonly spoken about now in the data engineering world. How do you see DBT's relation to this transformation to so-called ELT?
Yeah, I mean, very much so. The great thing that ELT approaches get you is sort of optionality. When you land raw data in a data warehouse, you have a whole universe of possibilities of how you want to reshape that data sort of in the database. And you have a lot more people that can actually do that work. So the ETL workflow, where you're sort of transforming data as it's extracted midstream, there's a certain kind of subset of people who can access those types of tools. And it means that all the logic is sort of locked up in sort of a maybe proprietary tool. The shift to ELT means that you can have an extraction loading process that's kind of like dumb, if you will. Just give me the raw data. And then you're free to adjust your business logic as your business changes or as you learn more about the data. So there's actually a whole lot to talk about as far as why you want to do this transformation work in the data warehouse instead of outside of it. But at the highest level, landing like raw unmodified source data in your data warehouse just gives you a ton more flexibility in the types of transformations you can build and who can build them and how frequently you can change them.
And does DBT, is DBT opinionated about the difference between a data lake and a data warehouse? Or for the purposes of this conversation, will we be using the terms interchangeably? Let's set some ground rules.
Yeah, so there are like a handful of words that are poisoned in my mind. They're like schema. Schema means absolutely nothing, absent a whole lot of context, and maybe like database or warehouse. We work a lot with what I will call data warehouses like Redshift, Snowflake, BigQuery. We also have built-in DBT plugins for Spark and Presto. And for many of these tools, there are ways to address data, whether it lives in physical storage on a cluster or in, say, blob file storage like S3 or GCS, whatever. And so to us, we care about being able to address the data in SQL. Just for our purposes, we say that that's a data warehouse, and we care less about if the data is stored in S3 or on a EBS volume on a Redshift cluster. Because take the Redshift case, you can address data in the database. You could also address data in S3. Does that make Redshift a data lake? Is it different than, is Spectrum different than Athena in that respect? We don't think it's an incredibly useful distinction for where DBT operates in the stack. As long as you write SQL to address and transform it, DBT is pretty happy.
Well, suffice it to say that in this whole move from ETL to ELT, it seems to me that one of the core concepts is the ability to shift a lot of the transformational data processing to the data source itself, the data lake, the data warehouse, which means that you don't have to have extremely structured data being dumped into that source in the first place. So whether you call it a data lake, a data warehouse, or whatever, it seems to me that the magic of DBT and its place in the ecosystem is inverting some of that transform process and giving you the power to do the transforms on a big heap of poorly defined or loosely managed data. And that seems to be the magic of DBT. Is that accurate?
Yeah, I think that's spot on. We see the advent, or really the rise of dedicated data loading tools like Fivetran and Stitch, which just have no context about how you want to do your reporting. And they're gonna load what we call source conformed data into your data warehouse. So it's like the exact representation from the data source. And then if you think about things in like an Airflow capacity, where maybe you're rolling your own ETL, it feels a little bit different. Like you do have an option in doing the data loading to start changing the shape of the data and maybe combining or aggregating data sets. The problem is you as a data engineer might not have the full context for how the company wants to analyze this data in the future. And when you start, say, aggregating data or maybe throwing away information that you don't think is valuable, like maybe it's not valuable today, but the business changes pretty rapidly. And so you're very much right. This shift that's really powered by affordable, scalable data warehouses is that you just land source data into the data warehouse. And then you have sort of a dedicated role of people who we call analytics engineers that sit at the intersection of database optimization and query tuning, but also deep context about the business. And you sort of empower these people to understand what types of analyses need to be done and what work needs to be done to get the data, like the source data, into the format where you can actually power those analyses. And it sort of lets everyone, find their spot in the data stack where they can be most effective. And it doesn't ask people to do, too many things all at the same time.
Got it. So Drew, I just wanted to call out before we go further that we have over 60 people from all over the world on the show so far, which is super exciting. And as you know, one of the format wrinkles that we're playing with here at DC Thursdays is to allow the ability of the audience listeners to ask questions midstream. So we're not saving questions for the end. I just want to encourage the audience and the listeners to feel free to type your questions into the YouTube chat. and we'll be taking them as we go, interspersed through the conversation. So before we start that, Drew, I just wanted to acknowledge that I probably met you in 2016 or 17 when DBT was really nascent and it was a baby little project. And I wanted to touch on this notion of the analytics engineer, because at that time, you guys had not sort of hitched your horse to this notion of the analytics engineer. You probably didn't know exactly how that was going to emerge. You probably didn't know how the data ecosystem was going to emerge. And so at that time, it felt to me like DBT was this really interestingly weird in-between tool that almost didn't have a place in the world. It didn't seem to be acknowledged by the data engineering community as such. They were all talking about Kafka and ETL, traditional ETL, and other things. And yet DBT was this kind of scriptable command line data transformation Swiss Army knife thing that seemed to allow non-data engineers to do data engineering type things. And I think it was a little bit confusing to the community at the time. Since then, you've obviously grown up, you've gotten big community adoption, you've figured out how to continue to articulate what it is you do, what your value prop is, and you've landed on this notion of the analytics engineer. So talk to me about the analytics engineer and sort of how that's meaningful and how you see that role emerging and how it's slightly different than a traditional data engineer.
Sure. I want to validate the thing that you said, which was that back in 2016 at the Brooklyn Naval Yard Data Council, I spoke to felt like 100 people about what we were trying to do, and it was a lot of like, oh, interesting, cool. Here's what we're doing in Airflow, and I was like, But you're right. It's very much it's a new role in organization. It requires a blend of different skills that we think a lot of people had before, but there wasn't a name to affix to it. And I think what's happened over the past 4 years is not, is really just a recognition of the fact that this is a good way of organizing work and a good skill set that people can really get into and grow in over time. So, okay. And I apologize. Your actual question was about analytics engineering, but what specifically?
What is it?
What is it? Okay,
how do you see it evolving sort of in the modern data era?
So, a powerful thing happens when you get data addressable in a data warehouse that's addressable with SQL. It means that anybody who can write SQL can both write and understand the business logic required to sort of operate on that data. So kind of what happened historically was you didn't have a dedicated part of your stack that was specifically for data modeling. You either did it as a part of ingestion or you did it kind of at reporting time, just-in-time data modeling. That looks like these really gnarly subqueries that you copy and paste between every report you ever make. And in either case, there are drawbacks. Take the reporting case. Sure, okay, I'm gonna make everyone on this call really upset. What's an active user in your company? It's generally not an easy question to answer, and it usually is mired in well, we have deleted users, we have internal users we don't want to count, we've got testing users that we identify by their VPN IP address. And so if you actually want to get a number right, there's a lot of logic that goes into this, and it might change over time. And so the goal for the analytics engineering profession is to sort of take all of that business logic and figure out how to represent it as what we call data models in a data warehouse. I mean, that's a very tactical version of it. The higher level answer is these are the people responsible for creating, organizing, and disseminating knowledge within their organizations. So the mechanism we see them employ is data warehouses and SQL, but it's actually a much broader thing than just typing data models all day. So, where did it come from? It was the belief that you just can't live with all these different reports where you're copying and pasting critical business logic between all of them. Things get out of sync. People have different numbers. It's slow because you're at, query time, kept recalculating, what a session is out of page views or something like that. And it's things, you have a lot more options to do a good job when you make this a dedicated part of the stack. And so the analytics engineers sort of live in and around the data warehouse, and they think a lot about what the data is that's coming in and what reporting is happening on top of it. And really what the data model is that should power the question answering for the whole business.
And would you say that an analytics engineer is a functional replacement for a data engineer in some teams? Do some teams have one and not the other, or do they coexist together in some cases? Like, how do you see that?
Yeah, we Fishtown Analytics for the majority of our early history, so like the first 3.5 or 4 years, we did a lot of consulting, and we would implement DBT. And it's a big part of why I think we struck a nerve with analysts. It's because like we were doing the work and we built DBT to help us do the work. And so as a part of consulting, we got to see every different data stack and organization practice you can imagine. We saw teams where they had 40 data engineers and 1 analyst. We saw teams where there were 40 analysts and 1 data engineer. And the reality is like, you kind of want to be somewhere in the middle. And the cool thing about promoting analytics engineering as a practice is it lets each of these different data roles kind of focus on what they're good at. So the data engineering case is interesting. We should talk about it. But the really kind of clear one is the data science use case, where every data scientist talks about how difficult it is to get clean data to actually like analyze. And they shouldn't necessarily be the ones that are doing all the heavy lifting in the data warehouse to sort of ETL data in, transform it in a way that it's clean and ready for, reporting or data science, whatever it is. And then only after like, a whole lot of front-loaded work can they actually do some sort of meaningful analysis. The really cool thing about having a separate analytics engineering function is that it's your job to create, clean, well-tested data sets in the data warehouse that power both data science and, say, more business intelligence type use cases. It means everyone's kind of operating off the same data. So that's one example where analytics engineering lets kind of data scientists downstream of the data, focus on what they're excellent at. On the sort of ingestion side, the advent of analytics engineering does not mean that data engineering is useless. It just means that, show me a data engineer that's really happy, like building data models for business users, and it'll be an interesting conversation. I'd love to meet with them. It's not to say that they don't do it. It's just that you're at this intersection of like deeply technical problems and, domain knowledge that you might not have or that might not be readily accessible to you. And from what we've seen, many data engineers aren't empowered to go work with those like domain experts and understand like what actually is the thing that you need. What's the question you need to answer, and how do we work backwards to a data model that can power it for you?
Got it.
So, just in sum, what we see is data engineers focus on infrastructure, like platform stuff, building custom ETL when it's warranted and necessary, reporting, like monitoring, performance tuning, all the stuff that's a little more like platform or deeply technical or requires like an understanding of, compression algorithms on Redshift or things like that.
And less of the transformation work.
Right. And so, we can talk about this too, but one of the great things about DBT is it allows you to build abstractions in a data warehouse and bring other software engineering concepts into analytics. And frequently we find that data engineers are incredibly helpful in kind of teaching the analysts on their team, like, here's why you want to build an abstraction over what a user is. Here's why you don't want to repeat it multiple times in every report that you make. Or here's how to think about modularity and break down this one really big table that's hard to grapple with into smaller tables that will kind of compose well together.
Got it. Well, let's go to some questions from the listeners.
Sure.
So first question is from Hafiz, and they're asking, what are your thoughts on the need to do ETL to deal with PII data? Masking, anonymization are examples. How would ELT fit that use case?
Yeah, it's a great question. Any of these privacy and security questions, like your mileage varies based on the nature of your PII and like regulations. But what we found works well for most organizations is like locking down access to the source data so that it's only accessible to the people who actually need to process it. Say analytics engineers. And from there, there are a number of different general tactics or database-specific functionalities that you can employ to mask PII, do one-way hashing, things like that. And in fact, a lot of people point to DBT as a really helpful way for them to like tag columns that contain PII, such that if someone requests like, please delete my information, you are able to sort of see the provenance of like, okay, I've got this data point. What are all the places we use it downstream? How does it all map together? And can I delete it? Can I hash it? Things like that. So, the thing I would say is like DBT doesn't take a strong stance on how you model your data. It just gives you the tools to do it yourself. So I'd rather have that ability and have to answer the question of like, what's the right answer for my organization and my needs, than sort of not have this as a discrete layer of the stack. I think the ETL case is pretty interesting. I do get how it would be compelling to just like not sync that data in the first place. The other thing I'd say is like, I think a lot of the tools out there, so maybe someone can correct me if I'm wrong, but I think Fivetran in particular might have the ability to mask certain PII columns at ingestion time. So, the answer might be it's a little bit of both. You're going to want to not collect data that you have no business analyzing, that you don't want in your warehouse in the first place, like credit card numbers, SSNs, things like that. But if there is like, say, PII, like an email address, and you need to mask it, DBT gives you an opportunity to write that transformation to do the masking and make sure that you know exactly where that data point flows through in the rest of your data stack.
In that regard, just to be clear, DBT supports complex multi-step transformations on data. So you generate your own DAG, if I'm not mistaken, and you give the users the ability to sort of manage, manipulate, and understand complex structures and layers of transformation throughout the data warehouse. Is that correct? So in that respect, like you said, you'd be able to track PII on the ingest and on the output. And because DBT is structured in both as a collaborative tool for your whole team to use, and in a way that supports a clear notion of like what transformations are happening at each step of the process based on its DAG, you have visibility into all of these things. And you also have the guarantee that you can transform your data consistently from one form to the other every single time, just by running the DAG. Is that correct?
Yeah, that's totally right. All of DBT's models are idempotent, and they can depend on other models, which means that you can rerun any part of your DAG whenever your logic changes or as you receive new source data. The other really, compelling part of DBT to talk about here is DBT's built-in like testing and documentation capabilities. So a DBT model is a SQL select statement that defines a transformation, and then you can write a test on top of that model that's more or less a SQL select statement or a sort of YAML configuration that asserts that something's true of the data. So if, for instance, you have an email column that you think is supposed to be always hashed, maybe it's a blend of different, identity inputs that all feed into like a users table. You can say like test that this column only contains MD5 hashes. Maybe a simple way to do that is like check for an @ symbol. And you can kind of encode that as an assertion about your data in DBT. DBT can then alert you if you receive new data that is not hashed. The reality is just like there's too many tables and too many columns for you to hold all of these assumptions about like reality in your head. And it's better to document them by writing a test and be alerted if they don't hold.
So you obviously, there's obviously a lot of things that DBT can do. I wanted to go to another question here because you touched on sort of the quality of data. Martin, hey Martin, is asking, related to a previous guest, Abe Drew, who the author of Great Expectations, was here talking about data quality. On the other hand, DBT has a powerful set of data quality tooling. Any word on the possible integration of Great Expectations and DBT?
Yeah, we think Abe and the Great Expectations team are one, awesome, and two, very clever. It's a great name, Great Expectations. It's something that We've kicked around a little bit. I think I actually met Abe at the last San Francisco Data Council event, and we had a chat in the hallway about what it could look like. It's an oft requested integration from people in the DBT community. So no concrete plans to implement them, but there is a lot of overlap, and I think they work well together. So I'd be excited to figure out a way that we could get the two speaking together a little more tightly.
Got it. So you're a product guy in addition to being an engineer, and you're running product at Fishtown. On that note, I'm curious, like, what is the big vision for DBT? Like, where do you see this going from a product standpoint? Flavian jumped in the chat and asked that as well, and I might be curious to hear your thoughts on the bigger vision for DBT.
Yeah. So, you know, we're a mission-driven company. Our mission's front and center at fishtownanalytics.com, and we've got a page that enumerates all of our values. And so, just like very plainly reading from the mission, we're on a mission to empower analysts to create and disseminate organizational knowledge. And the kind of big idea there, you know, when you understand what DBT is and how we're empowering these analytics engineers, you kind of get a sense for tactically what we want to do with DBT. But when you take a few steps back, the idea is just that there's, you know, the most innovative organizations in the world are using data today to make decisions. And the pace at which data is collected is just accelerating for like every modern organization. And so trying to make sense of it becomes a harder and harder and more valuable prospect. So, you know, we talk about the world in terms of like data models and data testing and documentation, but really at a high level, what we're trying to do is help folks organize the knowledge that their businesses command and make it accessible to different people trying to answer questions so they can move the business forwards. So in that light, you know, you can see threads of this. Like we've built an open source documentation website that ships with DBT, where you type, you know, DBT docs generate, DBT docs serve, and you get a web page. It's like a static website that shows all of the models in your data warehouse and documentation about, you know, the tables and columns and things like that. So it's kind of an early start, but it's super aligned with our vision of the future, which is like, yeah, creating tables is great and really helpful, but people need to know what data exists, is the quality up to snuff, like do our assumptions about the data hold, how recent is it, are people using it, things like that. And those are really the big questions we're interested in answering. And I think that it's a deep well, like the version of DBT that exists today, I think a lot of people credit with bringing this organization to their companies, where actually people can look at a data warehouse and see like, okay, I know what the gold star data is. I know where to find the definition of a user or where to find the definition of an order, which is not always an easy thing to do. And sort of the next iterations of our vision will have us building tooling to help these analytics engineers push the data out to more people and make sure that folks understand where their data is coming from, like what's the provenance, how recent is it, can I trust it, and kind of close the loop. Like we joke a little bit about, I think Amundsen does this, but like it's an NPS score for your data set. Like I would recommend this data set to a friend or colleague. I think is really funny, but a good idea. It's like, it's not a one-way street. We need to figure out a way to get the data to the consumers and then have the consumers kind of loop back around and say like, yes, this was valuable, more of this, or like, this didn't answer my question, here's what I need instead. It's just not from what we see, a super strong bond that exists in most organizations. And that's, you know, part of the vision too.
So you mentioned the analytics engineer again, and Francisco is asking in the chat, is analytics engineer just a rebranding for a BI engineer? What's the difference between the two?
Good question. You know, there's a lot of titles out there. This is a rebrand of BI engineer. I think they're more similar than they are different. If there's any meaningful distinction, it's that analytics engineers own more than just the BI piece of it. It's like they are responsible for, you know, we see a lot of companies switching to using data warehouses, like modern data warehouses, as a single source of truth for their entire business, and they break down silos, and you hear these words on sales calls with data warehouse vendors sometimes. And the idea is if your goal is to put all of the information about your business into a data warehouse, then the curators of that data warehouse are like the librarians for your company. And we think of the analytics engineer almost as, the librarians of the data, making it like addressable and accessible and documented, tested. So not that librarians do a lot of testing, but so be it. So is that a meaningful distinction? Did BI engineers do that previously? Yeah, I'm sure. The maybe thing I could say is it seems like the title analytics engineer feels a lot more resonant for people doing this work than I think BI engineer does, because it's a lot more than just BI.
And so along with that, the suite of features that DBT supports, testing, documentation, data quality, etc. It seems to me like you're trying to usher in parallel concepts from the software engineering world into the analytics engineering world. Is that part of your mission? Do you feel like this is part of the purpose of DBT? And how would you articulate that?
Yeah. So it's funny because I talk about this a little bit differently depending on the audience, and maybe for this technical audience, I'll call it how it is. We very much, let me say it this way. Analytics for a long time was the Wild West, where folks were just like making it work. And you did get these like 1,000-line SQL statements with nested subqueries inside of nested subqueries. And somebody left the company and nobody knew how the table got there that powers all the reporting. And our inspiration was just like, well, SQL is code, and there exist modern best practices for how to manage the creation and modification of code. And so how many of those ideas can we take from software engineering and apply them to analytics? And that gets us things like, version control, code review, automated testing, sort of like a separation of development, staging, and production environments. And there are sort of ways to do all of those things using DBT. It's a framework that is supportive of a modern software engineering workflow. And the piece I said at the beginning about calling it how it is, I follow a lot of what I would consider pretty wise, seasoned software engineers. And I think if you ask them, has software engineering answered all the questions about how to build software? They would say like, no, we have so much work to do as an industry to actually build the good tooling. And these are all the problems. And here's what we want to fix. So, for this audience, I would just want to claim like a lot of our inspiration comes from software engineering, but we also recognize that it's still a developing topic. Like the best way to write software, it's an unsolved problem. And the same is very much true in the analytics space. We just think it's a good starting point.
So in terms of the greater data tooling ecosystem, we already touched on other projects like Great Expectations. Are there some other tools? You mentioned Airflow previously. Are there tools that you play nicely with that you see commonly deployed surrounding or next to DBT?
Yeah, sure. There's, we receive a lot of questions about Airflow, like, does DBT replace Airflow? And for us, we feel that focus is kind of one of the key features of DBT. So DBT works super well with Airflow. I think it's cool because I love DAGs, and I love the idea of this sort of like fractal DAG where you have Airflow that spreads out into your DBT DAG of transformations, and you kind of let each tool do its own thing for what it's good at. So we work super well with Airflow. There's a lot of folks deploying DBT as an Airflow job. We increasingly are seeing more of tools like Dagster and Prefect, who I think are sort of like maybe you can say iterations on the Airflow theme. And that's super promising as well. There's really cool things that you can do with both those platforms. Nick Schrock in particular, I think gave a great talk at a recent data council that I really liked. And what are some other tools? Yeah, Great Expectations was third around. DBT is an open source tool. Its beginnings were on the command line. These days we have, a web interface too that you can use, but still today you can pip install DBT, type DBT run on the command line and get going. And you were inspired by things like the Unix philosophy, like do one thing and do it well and make sure that you're composable. And so we try to give good interfaces for people to tap into where we don't need like a first class integration with Airflow to be useful. Like there's a way to address DBT from Airflow. And that really opens up the universe of, people with their existing tooling, whether it's like Jenkins or Airflow or is cron tooling, you can still use DBT.
Well, and part of this is because of the flexibility of DBT command line tool, right? This was the origin of DBT was at the command line. And so it seems like that did allow DBT to get integrated into various types and steps of pipelines and transformations. So it sounds like you're continuing to see that kind of adoption as well.
Yeah, very much so. There's a question you asked earlier that this kind of reminds me of, which is how do different folks in an organization like work with DBT? And so you do have, say, data engineers who might be pretty happy on the command line. You might also have analysts that are newer to Python environment management and running things in the command line and setting up their text editors. And one of the really cool things about DBT is we've given folks ways to either write your models on the command line or in the browser on DBT Cloud, which is a hosted product that kind of sits around DBT. And the neat thing is you can write the code wherever you want, but you can still have the same conversation with people that are sort of operating in one environment or another. And you could have a conversation about, the data models that you're writing and a pull request on GitHub, regardless of like where you're actually writing the code. So we really do try to address both more people with an engineering background versus people with a non-engineering background, making sure that as long as you can like type SQL and kind of read through the DBT documentation, you can hit the ground running with DBT.
So talk to us a little bit more about DBT Cloud, because that's a newer thing to me that I know is one of your newer products built around the DBT core. What are the other benefits of cloud, and how does that affect the way an organization uses DBT?
Yeah, so there are a bunch of open source companies out there, and everyone kind of takes a different approach on how they, have a company that needs to pay bills while also like promoting the development and growth of open source software. And we landed on a what we would call a loose open core model, where DBT core itself, the open source thing, is fully capable and can, connect to different databases and issue transformations and kind of does everything you need to do for DBT's core value prop. DBT Cloud then sits around it and is sort of two or three big things. One of them is a job scheduler. So say, there are a lot of folks out there that are analyst teams of one at an organization, and it would be too much for them to like set up Airflow and monitoring and collecting logs and things like that. Kind of all by themselves. What they really want to do is start making data models and start building dashboards and start helping the folks in their company. So DBT Cloud's a super easy way to kind of stand up a scheduled run of DBT. It'll, clone your repo, execute DBT on a schedule, show you the logs and notifications if like a run fails or if a test fails. That's kind of one half of DBT Cloud. The other big half is a development environment. So we find that DBT is also super useful, not only at companies with one analyst, but like dozens and dozens or hundreds of analysts. And we find that there's a lot of heterogeneity and that's the right one, and the skill sets of these folks. And so there are people who are really happy on the command line. There are people who it's too abrupt a change to say, okay, you want to build a data model, fix your Python environment, figure out how to pip install DBT on Windows, which can be tough these days. And then muck with some credentials in a hidden folder in your home directory, and then learn how to navigate the command line with like CD and ls. These are good skills. We think folks should learn them if they're going to do significant, code development, which is what we think building a DBT project is. But it's a little bit too much to ask folks to do upfront. And so what we're trying to do with the DBT IDE is build sort of like a sensible upgrade path where you can pop into a web browser, start building data models, run them, build things in your development environment, click around them, see what happens. It's like a built-in Git workflow so you can do a real version control flow. And over time, we hope that the IDE is compelling enough that folks will like really enjoy it and the native DBT integration and the UX that comes with it. But we also understand like we think local development's awesome. It's why we set out to build a command line tool that, the primary interface was like, for me, Vim, for my colleagues like Adam or VS Code. I would never hold that against someone if they say, I want to take the next step and learn Vim. Well, I would hold that against some people. You shouldn't do it in 2020. Just kidding. So it's a natural progression,
Yeah, so on that note, I just want to highlight for the community that in case you haven't used DBT, and Drew, you can explain more, but there's a whole set of, there's a templating language, which I believe is based on Jinja, correct?
Yeah, that's right.
There's the templating language, there's variable support, there's package support. So I think this is one of the most appealing things about DBT to the early users was that it gave you a way to uniformly parameterize your SQL and turn it into control flow structures without needing to use proprietary PLSQL or some other transact SQL variant baked into that was tightly coupled with a particular RDBMS. So Drew, I assume that's been like one of the huge leverage points around writing your code in DBT templates with SQL inside them is the ability to really, for a programmer type, to feel like they got leverage over traditional programming structures.
Yeah, so it's a powerful tool that folks must wield responsibly. So you're totally right. DBT ships with the Jinja templating language. It is staggering how similar building out SQL statements feels to building out websites, where you've got some components you want to reuse kind of all over the place, or where you kind of want to do basically the same thing 12 times, but with slightly different semantics. And so DBT's Jinja support is specific to kind of rendering, or what we would say compiling, a SQL statement that runs against the database. So maybe you want to just say, often you want to like pivot out a table. So like show me the count where this column had this value and you've got 100 different values. You want to pivot out to 100 different columns. So you could write all that by hand. You could use, say, stored procedures or database specific functionality, or you could do it with DBT. And so what you can kind of do is like write a for loop that will loop over an array of 100 values. And you can say sum of case when value equals the first thing, 1, else 0. And you're sort of writing the script that generates the code that DBT will actually write against the database. So it's a really powerful thing. We find that, folks, when they have that ability for the first time, they sort of have a tendency to over template things and never repeat the same line of code twice, like macroize everything. So, we think a lot about finding ways to keep code dry, like don't repeat yourself, but also acknowledge that sometimes repeating things isn't the worst thing if it's a little bit more readable. So just another one of those cases where it's like a powerful tool and sort of up to the implementer to decide what the right way to employ it is.
So CooStuff has a question about Jinja. He's commenting that Jinja compiles the templates during compile time, but they're wondering, is there any plan to introduce write templates for runtime execution instead?
CooStuff, I'm unsure that I understand what you're thinking here. It's a neat question. Right. Pete, do you know what CooStuff might be thinking? I might be being
Well, I know that DBT has this notion of compiling SQL, but I'm not a deep user of the product, so you'd have to explain what that really means more.
Okay, so right on. Here's what I could say. DBT does kind of look like a more standard compiler. It takes a sort of like parsing pass where it looks at all the files in your DBT project. It parses out the representation and sort of the dependencies between different nodes in the DAG. And also any configuration that you apply. So like create this model in the database as a view or a table, sort of a parsing step. Then we do a bit of like what I think of as a linking step, where it's like, okay, actually build out the DAG of how all these things relate to each other and validate it, make sure there are no cycles or no references to things that are not defined. And there's sort of a runtime step. And that runtime step is where DBT starts at the roots of the DAG and just kind of executes things as it goes in parallel. So, my key question here is like, I don't totally understand the runtime execution piece, because DBT does sort of, in fact, take another pass at runtime where it will actually generate the SQL that gets run. So the interesting thing is like, DBT is a compiler. When it's parsing out a model, say you've got 100 models and you're looking at the first one, and your first one references a model that you haven't parsed yet. Well, you can capture the reference, but you actually don't know, and maybe this would make more sense for the code, but for any DBT users out there, you don't know what the ref evaluates to at parse time because you haven't parsed all the nodes yet. So at runtime, we re-execute the template. We have full information of the DAG, and we can render out exactly the SQL that you want instead of just like capturing your intentions and holding on to them for later. It's kind of like a two-pass compiler.
Got it. That's super helpful. CooStuff is also asking about the plan to introduce adapters for other databases. And someone jumped on and asked for Athena.
Yeah, I mean, I've got good news. We built DBT with a database plugin architecture. If you actually follow the, what I think of it like as archaeology, you could like look through the code and get hints of like civilization past. We built DBT initially, it only supported Redshift. We later wanted to add support for Snowflake, and we were like, well, we can decide that there are two databases that DBT supports, or we can make it a sort of plugin system where you can just meet an interface for connecting to a new database. And so today, DBT ships with support for Postgres, Redshift, Snowflake, and BigQuery, but there are kind of external plugins that live in their own repos, some maintained by us, some not, for Presto Spark, very much Athena under active development. There are two SQL Server plugins. We've heard about a vertical one, and someone's working like a Green Plum. Is that a database? I think based on Postgres. Mm-hmm. So if you can run SQL against a database and execute like create table and create view statements, you could build a DBT plugin for it. And there is very much an Athena one out there. If you join the DBT Slack at community.getdbt.com, you can hop into the DBT at the Athena channel and talk with the maintainers.
Awesome. I wanted to make sure that we covered that specifically, how folks can join the DBT community. We have another question about someone asking about setup on Windows, and it sounds to me like something maybe we shouldn't dig into here directly, but I'm sure someone on the DBT Slack would be able to help. So that's community.dbt.com, true?
Yeah, community.getdbt.com.
.getdbt.com,
yeah.
Great.
I'll answer the Windows question. I won't hide from it.
All right.
We love Python, and Python, in our experience and opinion, is the programming language, the programming language for data. I think R is cool too, but we don't see the wealth in the ecosystem around it quite like we do in Python for like maybe data engineering specific stuff. And one of the really tough things about Python is that packaging and distribution are like not solved problems today. We've kind of worked towards a better solution on Mac, where we make like homebrew distributions that help a little bit, but on Windows you're still pip installing, and Python doesn't make it easy to do a good job. So we're happy to help you with your specific problem in the Slack, and we remain interested in other distribution mechanisms like I don't even know enough to say, but I think I heard about a tool called Chocolatey once that could be relevant. It's a little bit too hard to install DBT on Windows today, and we'd like to fix that.
Got it. Well, we're almost out of time. I wanted to ask you a little bit about the future, Drew, and what are some upcoming features about DBT that you're particularly excited about?
Yeah, the central data structure in DBT is the DAG of all your models, and behind the scenes, the way DBT represents your DAG is you sort of have data models that depend on your data sources, and you have tests that depend on the models. And there are other ways that we sort of annotate this DAG with really helpful information. And so some of the stuff we're working on next is giving more powerful tooling around operating on that DAG. So for instance, today you can say, I just got a new load of Salesforce data, run all of my models that depend on Salesforce and everything downstream of them. But in the future, and one of the things we're working on now is supporting like kind of graph set intersection. So you can say, run all of my models that depend on Salesforce and are tagged with the hourly tag. It's like not a thing that you could do before. And there are really specific use cases that are super powerful that we kind of unlock by supporting this. Beyond that, and maybe we don't have quite enough time to dig all the way in, but I'll be real quick about it. There's, DBT has a notion of different environments. So you can have a development environment, kind of a staging environment, a production environment. It means different things on different databases, but just imagine like you've got a different schema where you build all of your transformations into. For me, it's called DBT Drew. Pete, for you, it would be called DBT Pete. And in production, maybe you call it prod. It means that you can sort of test out new models by building them into your sandbox schema without stomping all over production. You can have multiple copies of the entirety of your DBT project in the database. And one of the really cool things is because every DBT model is idempotent and graph aware, when you open a pull request in GitHub, GitLab, you can automate the creation of a new schema that's like identified for that PR. And you can build all of your DBT models into it. And then you can run all of your assertions and make sure the tests pass. So this gives you like a little check mark in the pull request. And you can do this in DBT Cloud today. But it's kind of a missing piece, which is that right now DBT needs to run the entirety of your DAG in order to tell you that like the one file that you changed succeeded or failed. And so one of the things that's coming too as a part of this initiative is kind of smarter, what we call node selectors from the graph. So you can say, I want to run my DBT project, but only the models that are new or changed since the last time I ran DBT and everything downstream of them, plus their tests. And then you can do that with intersection. So it's like run everything that's changed that's also not tagged with the, that's actually a set difference. Say not tagged with like, don't run in CI or something like that. It's just like more powerful tooling for development and deployment of DBT.
Neat. That sounds super compelling. Look out Airflow.
They work well together.
Awesome. Well, lastly, you guys just raised a bunch of money, so congratulations on that. I know that your team is growing. So where can folks who are interested in potentially working with DBT and Fishtown find you? Yeah,
right on. We're one of those companies that has a different name from our product. So the company website is fishtownanalytics.com. The background is that Fishtown is a neighborhood in Philadelphia where we started the company. The thing I'm hesitating to say is like we were never quite in Fishtown. We were across the street, but pretty close enough. And you wouldn't know it if you live outside of Philly. So fishtownanalytics.com, there's a link to the jobs page. You can check out like our mission and values. We're a strongly mission-driven company. And in particular, if you're interested in maybe working with us on what we're building, check out our values and see if they resonate with you. We care a lot about creating more value than we capture and moving up the stack. Awesome. Well, Drew, thanks for being a member of the Data Council community for all these years. It's been really great to have you. And thanks for joining us on the show today. It's been super helpful for the community, and they're all appreciative as well. Yeah, thanks a lot, Peter. It's truly my pleasure. Thank you.